Ask My Instructor 15.2.45. Given the force field F, find the amount of work required to move an object along the line segment from the point 411 to the point 255. The first thing we're going to want to do is find a parameterization of the line segment. And these are the steps. Notice that our starting vector, is just 411, and that's taken from the point P naught, 411. Now, to find the velocity vector v, we're just going to find the difference between the vector going to P naught and the vector going to P1. So do that, and you get v is just 255 minus 411, and so v is equal to 1644. Use R naught and v to find the parameterization. R, the parameterization, is going to be just 411, our starting vector, plus that velocity vector, 1644, times t. All right, and so we have our parameterization. Now notice that when t equals 0, we are at our starting point 411, and when t equals 1, we are at the end of the line segment 255. So our parameterization has t running from 0 to 1. All right, and we're going to use this to find the line integral. First, let's find r prime because that's the easiest piece. R prime is just the velocity vector. See how it all works together. So r prime is our velocity vector, 1644. And now let's find the force field on the line segment. All right, so we're going to use the parameterization to describe the force field. And let's first work on the denominator, x squared plus y squared equals z squared. All right, just plugging in what x is on the line, what y is on the line segment, and what z is on the line segment. And then a little bit of cleanup. Rather than squaring all these things, I think it's a little bit smarter to recognize that 4 plus 16t can be written as 4 times 1 plus 4t. And when you do that, you can see that x squared plus y squared plus z squared is just 18 times the quantity 1 plus 4t squared. All right, so we have our denominator. We just put in what x is, put in what y is, and put in what z is. And notice that we can clean this up. I'm going to divide of this force field, I'm going to divide the top and the bottom by 1 plus 4t. And when I do that, I get a simplified form for the force field. All right, so we have our parameterization, we have F, and we have the velocity. Let's find F dot R prime. F dot R prime, we set it up, and then find the dot product, and then just clean it up. And we get 4 over 1 plus 4t. All right, using the parameterization, the line integral becomes this definite integral of 4 over 1 plus 4t, where t runs from 0 to 1. Now we need to integrate this. Notice that to integrate this, this is just a log integral. I have, if I have u equals 1 plus 4t, du is just 4 dt. So this is, in essence, du over u. And so du over u has an antiderivative of ln of u. So when we go to integrate, we get ln of 1 plus 4t, where t runs from 0 to 1. So evaluate this, and I get log 5 minus log 1. Now log 1 is equal to 0, so my answer is log 5. So given the force field, the amount of work required to move an object along the line segment is ln of 5 units. Take care. Have a great day.